Okay, let's dive right in. You're hearing a little piece of music right now. Think about this. It was created entirely by AI using digital instructions generated by a fascinating project we're exploring today. Pretty wild, huh?
It really is.
Stick with us.
Yeah.
Because understanding how this music was made and what it means, that's where things get really interesting.
Yeah, what's fascinating here is seeing how computer intelligence can now be, well, a real partner in creativity. That little musical snippet you're hearing, it's direct evidence of this project's potential, and it really opens up some exciting new frontiers.
Absolutely. Welcome to the special presentation of the Deep Dive. We're taking an inside look at this AI-powered music creation project. And whether you're, a seasoned musician, maybe a tech enthusiast, or simply curious about the cool things happening when AI meets art, you come to the right place. We're going to unpack the core technology that makes it all work, something called MIDI, and explore the amazing possibilities this project unlocks for making music.
And don't worry if you don't speak fluent tech or music theory. We're here to guide you through it. Our goal today is really to give you a clear understanding of what this project is all about, the fundamental role of MIDI, and what this could mean for anyone interested in creating music.
Right.
And yeah, that soundtrack you're enjoying, that's pure AI-generated MIDI from this very project in action.
So let's lay the groundwork then with something fundamental, MIDI. You hear about it a lot in electronic music, but what exactly is it?
That's the perfect place to start, yeah. When you think of music, you naturally think of sound, right?
Sure.
But MIDI, which stands for Musical Instrument Digital Interface, isn't sound itself. Instead, it's a way for musical instruments and computers to talk to each other, a set of digital instructions.
Okay.
Think of it like a kind of digital version of sheet music. It doesn't contain the actual sound, but it tells instruments and software exactly what needs to play.
Digital sheet music. Okay, that's a really clear way to picture it. So what kind of instructions are we talking about? Like what information is actually stored in a MIDI file?
Right. So a MIDI file holds a surprising amount of detail. It specifies which note to play and how hard it should be played. We call that velocity,
Okay.
It affects how loud or soft the note sounds.
Velocity, got it.
It also tells the instrument precisely when to start and when to stop playing that note. And crucially, it dictates which instrument should be used to create the sound. Could be a piano, a drum kit, a synth, whatever.
Okay.
And beyond those basics, MIDI can also carry other control signals like changes in volume, panning, the left-right placement of the sound.
Yeah, in your headphones.
Exactly. And, well, much more besides.
Okay, so it's a very detailed set of performance directions.
Yeah.
What makes MIDI such a powerful tool in music production then?
The real magic of MIDI, I think, is its incredible flexibility. Because it's data, not a fixed audio recording like a WAV file or an MP3. You can easily change pretty much any aspect of a musical performance after it's been recorded. Want to correct a wrong note?
Oh, Andy.
Yeah, or tighten up the rhythm, experiment with a completely different instrument sound. You can do all of that with just a few clicks in a DAW.
DAW. Okay, we've all heard that term. Maybe quickly explain what they are and how they work with MIDI.
Sure. DAWs, or digital audio workstations, are basically the central software studios for modern music creation. Think of popular programs like Ableton Live, FL Studio, Logic Pro, Pro Tools. There are quite a few.
Right, the big games.
Yeah. They provide a complete toolkit for recording, composing, editing, mixing, mastering music, all inside your computer.
So how does MIDI fit into the picture with these DAWs then?
Well, DAWs are specifically designed to work hand in glove with MIDI. It's fundamental. So when a musician plays a MIDI controller like a MIDI keyboard, the DAW receives those MIDI messages, those digital instructions we talked about. The DAW can then use this MIDI data in a couple of key ways. It can trigger virtual instruments. These are like software-based synthesizers, digital pianos, drum machines, all living inside the computer to generate the actual sounds you hear.
Oh.
Or the DAW can simply record the MIDI data itself. And this lets the musician go back later and fine-tune every single note, its timing, its intensity, even change which virtual instrument is producing the sound entirely.
So if I'm understanding correctly, MIDI is kind of like the blueprint.
Yeah, that's a good way to put it.
And the DAW is the workshop that uses that blueprint to either build new sounds with virtual instruments or to reshape existing musical ideas. It's like having the composer, the orchestra, and the recording studio all inside one piece of software.
Exactly, you've nailed it. And that's the exciting context for understanding this AI MIDI project, is taking this incredibly versatile foundation of MIDI and combining it with the groundbreaking capabilities of generative AI.
Okay, so let's talk about the project itself.
Yeah.
What was the spark for it? What problem were the creators, trying to solve?
Right. The project really sits at the intersection of electronic music creation, the adaptable nature of MIDI, and the innovative power of generative AI. The core idea, really, was to address a very common hurdle: creative blocks.
The bane of every creator.
Tell me about it. So imagine being able to describe a musical idea you have in your head, even if it's just a general feeling or a desired vibe using everyday language, and then having the AI instantly generate a MIDI pattern that you can use as a starting point. Like, you could say, a driving house beat around 125 BPM, and the AI could give you a drum pattern, maybe a bass line, almost immediately.
Wow. That sounds like an amazing way to jumpstart the creative process. So it's about moving beyond the AI just randomly spitting out notes.
Exactly.
And getting something that actually aligns with what you're imagining.
Precisely. The aim is what we call semantically controlled creation. Your natural language description guides the AI to generate music that fits a specific style and mood, rather than just relying on chance or randomness. Think about how someone without years of music theory could describe a feeling and instantly have a musical foundation to build upon. It could open up entirely new avenues for creative expression.
Okay, this is fascinating. So how does the AI actually do that? How does it understand our musical desires expressed in words and translate them into those precise MIDI instructions? What are the key technical components at work here?
Well, there are several important pieces working together. First, there's natural language processing, or NLP.
NLP, right.
The project uses something called regular expressions. Think of these as special search tools for text.
Right.
To identify key pieces of information in your description. Things like the tempo, BPM, the musical key, the level of complexity you're looking for, and the type of musical pattern you want: drums, bass, chords, etc. It's like the AI is scanning your request for the essential musical ingredients.
So the AI is essentially like reading our minds musically, pulling out the key details. What happens next?
Okay, so after it pulls out those initial details, the AI needs to grasp the underlying meaning of your request and connect it to different musical styles. This is where text embeddings come in, using something called sentence transformers.
Text embeddings, sentence transformers.
Yeah.
Okay.
Yeah. Both your natural language description and a vast library of descriptions for various electronic music genres are turned into numerical codes called embeddings. Imagine the AI turning words into a kind of hidden code where similar musical ideas get similar codes. It lets it find connections. These numerical codes capture the core meaning, the semantic meaning of the text.
Okay, so now we have these numerical representations, these codes for both what we're asking for and what different genres sound like. How does the AI figure out which genre is the closest match? That sounds complex.
It could be, but that's where efficient vector search comes in, using a clever library called FAISS. FAISS is like a super fast librarian.
Oh.
It's designed for searching through a huge catalog of these numerical codes, these vectors, to find the closest match to what you described. It allows for a very quick and, importantly, scalable comparison between your request's code and the codes of all the genres in its database.
Scalable, right? So it can handle lots of genres.
Exactly.
Right.
Which is crucial as the range of musical styles the project can understand continues to grow.
So the AI now has a good sense of the musical direction, the genre we're aiming for.
Yeah.
How does it actually generate the MIDI data, the notes and rhythms itself? This is where the generative AI part comes in, right?
Yeah.
Using Google Gemini.
Exactly. The Gemini model is the core creative engine here. It's instructed very specifically to generate the musical pattern, the specific notes, how long they should last, which virtual instruments should play them all in a very organized and predictable format called JSON. Yeah, JSON, think of it like a very structured recipe. It has clear ingredients and instructions that the computer can easily follow. This structured output is essential for reliably turning the AI's musical ideas into actual MIDI data that the system can process.
That structured output sounds key, yeah. To make sure the AI's musical ideas are actually usable. What else is Gemini doing in this process? Is it just generating?
Well, interestingly, no. The Gemini model also acts a bit like its own music critic.
Really? How so?
Once it generates a JSON representation of a musical pattern, it evaluates it based on several criteria. how well it fits the identified musical style, how musically coherent it sounds, and whether the JSON structure itself is technically correct. It even gives the generated pattern a score and provides feedback on what it thinks works well and what could be, improved.
That's fascinating. So the AI isn't just generating and hoping for the best, it's actually assessing its own work.
Yeah.
How does that self-evaluation help the music get better?
This leads to another powerful technique they're using called retrieval augmented generation, or RAG.
RAG.
The initial request, the prompt that's sent to Gemini to generate the music, is actually enhanced. It's augmented with the description of the musical genre that was identified as the closest match through that vector search we talked about earlier.
So it gets context.
Precisely. It gives Gemini crucial stylistic context right from the start. Then, the feedback from Gemini's own evaluation, that critique, it gets fed back into the prompt for the next attempt at generation.
Oh, I see.
It's an iterative process. The AI tries to refine the musical pattern based on its own critique, attempt after attempt, within limits, of course.
So it's a cycle. Generate, evaluate, refine. Does the system rely entirely on the AI for these improvements, or are there other checks?
Not completely. The project also incorporates what's called heuristic correction. This involves specific bits of computer code written in Python that automatically try to fix common errors or inconsistencies in the AI's output.
Like what kind of errors?
For example, making sure the total length of the musical pattern makes sense mathematically, or fixing overlaps that shouldn't be there. It's like a final automated check to ensure the generated MIDI data is actually valid and usable on a DW.
Okay, right. So we've got the language processing, the genre matching with embeddings and vector search, the AI generation and self-evaluation using Gemini and RAG and these automated heuristic corrections. What's the very final step in getting a usable MIDI file that musicians can actually work with?
The very last piece of the puzzle is the conversion. Taking that validated JSON structure, the structured recipe, and turning it into a standard MIDI file. The kind of file usually ending in .mid that any DW can easily open and play. This is done using a Python tool called Pretty MIDI, which handles all the technical details of creating that standard MIDI file from the structured musical data.
Wow, okay. That's a really sophisticated process happening behind the scenes.
Yeah.
So just to recap, the AI's capabilities that this project really demonstrates, we're seeing embeddings, vector search, retrieval augmented generation, RG, structured output in JSON format, and even the AI acting as its own initial quality control, its own critic.
Exactly right. And the combination of all these technologies, well, it unlocks some truly exciting benefits and possibilities for anyone who creates music.
Like what? Let's talk about that. What can musicians actually do with a system like this in their creative workflow?
Oh, the potential is huge. For starters, it allows for incredibly rapid prototyping of musical ideas.
Right, that speed you mentioned.
Yeah, you can go from just a vague concept in your head, maybe just a feeling, to a tangible MIDI pattern in moments just by describing it in plain language. It's also, I think, a fantastic tool for sparking inspiration and overcoming those frustrating creative blocks. If you're feeling stuck, you can ask the AI to generate different ideas in various styles just to push you in new directions. It's kind of like having an endlessly creative collaborator on tap.
That sounds amazing. Like having an AI co-pilot for your musical journey.
Yeah.
What else does this open up?
Well, exploring different musical styles becomes incredibly easy. You can quickly hear how a particular musical idea might sound in, say, techno versus house versus something ambient, without having to manually program everything from scratch.
Yeah, that would take ages normally.
It could. And this could even lead to the creation of entirely new hybrid genres, maybe born from the AI's interpretations. Furthermore, it can definitely lead to the development of new kinds of assistive tools for musicians, helping with composition and arrangement in ways we probably haven't even fully imagined yet. And perhaps most significantly, you can continuously refine your prompts and maybe even tweak the AI's evaluation criteria to guide it towards your own unique artistic vision. It becomes a truly customizable and evolving creative partnership.
It really sounds like it. So we've taken quite a deep dive here into the technology powering this project, from the fundamentals of MIDI right through to the cutting-edge AI techniques being used.
Right.
What are the key takeaways you'd want our listeners to remember, especially considering, the music they heard at the start was created using this very process?
Yeah, that's the key, isn't it? The core idea to remember is that this project makes it possible to generate MIDI-based musical ideas using simple natural language, all powered by AI. It cleverly uses MIDI's inherent flexibility and the sound design capabilities of DAGAs to bring these AI-generated instructions to life. We've seen how techniques like embeddings help the AI understand musical intent, how vector search finds relevant stylistic context, and how generative AI models like Gemini can create musical patterns, even evaluating and refining their own output using things like RAG and self-critique.
Right.
And it's crucial to remember, like you said, that the music you heard at the beginning of this deep dive is a direct result, a tangible outcome of this exciting intersection of AI and MIDI.
And this really feels like just the beginning, doesn't it? I mean, where could this go?
Oh, absolutely. The team behind this project is already looking at some really exciting future developments. Imagine even more sophisticated ways for the AI to assess the musicality of its creations, not just technical correctness. Support for a much wider range of instruments and articulations, how they can be played with different techniques.
Yeah.
Perhaps using more advanced AI tools like function calling, maybe even training specialized AI models just for music generation, and of course developing a user-friendly interface to make all of this powerful technology even more accessible to everyone.
That paints a really inspiring picture of where music creation could be headed. So, as we bring this deep dive to a close, here's a final thought for you, our listener. Now that you've heard how AI can understand musical intent and generate these starting points in MIDI, how might this kind of technology influence your own approach to making music? Whether you're a seasoned producer or maybe just starting to explore your sonic curiosity, it really makes you think about the collaborative potential between us humans and AI, especially in the world of sound.